Welcome to day 51 of our school year. Starting a new row here. Alright, our beginning fraction. Our denominator is our total amount of school days, and we are on day 51. So we have to think, is 51 prime or composite? Well, it's not an even number, so I can't tell right away, but you know what? 5 plus 1 is 6, and 6 is a multiple of 3. So that means 3 is a factor. That means it's composite. And if you check, 51 is not circled because it is a composite number. So that means we need to do our prime factorization of our denominator and of our numerator. And remember, our first 5 prime that we use 2, 3, 5, 7, 11, and so on. Okay, so if we start with our denominator, it ends in a 0. So I know that 5 is a factor. I can't get any groups of 5 out of 1, but out of 18 tens I can get 3 tens. 3 times 5 is 15, and then it leaves 30, and that would be 6 groups. 3 plus 6 is 9. 9 is a multiple of 3, so 3 is a factor. I can get 10 groups of 3 out of 30 and 2 groups of 3 out of 6. That's even, so I can divide by 2. That's even, so I can divide by 2. And when I get to a prime number, I am done. Okay, I already said that 5 plus 1 is 6. 6 is a multiple of 3, so that means 3 is a factor. I can get 1 group of 3 out of 5. 1 group of 3, 10 groups of 3 out of 50. And that leaves 21. Well, 7 times 3 is 21. 17 is prime, so we are done. Let's list our prime factorization for our denominator. We go from least to greatest. 2 times 2 times 3 times 3 times 5, and 3 times 17. So let's see what we have in common. We have 3 in common, so our greatest common factor is 3. That leaves 17 in the numerator, and 2 times 2 is 4, times 3 is 12, times 5 is 60, 17 sixtieths. But let's go ahead and prove that. Let's make our groups of 3. Remember, your groups do not have to look like mine, but you want to keep your shaded separated from your unshaded, and you want to make sure that they have 3 in each group. So we're doing our division with our model. When you divide, you're doing repeated subtraction, or we're putting them into equal groups. So I have now all my equal groups. I want to count up my total groups of 3. Well, each of my rows has 3, so I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 55, 56, 57, 58, 59, 60. 60 total groups. And I have 3, 6, 9, 12, 15, 16, 17 shaded in. Alright, so we've done our division with our model. Let's go ahead and prove it with our algorithm. Remember, in algorithms, just a step-by-step way of solving a problem. We're going to use our area model here. Okay. 180 divided into groups of 3. 51 divided into groups of 3. So let's see, if I did 50 times 3, placeholder moves it over a place. 5 times 3 is 15. Numbers the same, zeros the game, more on top, no need to stop. I can take more groups of 3 out of 30, so I'm going to bring the 30 up here. And I can do 10 times 3 is 30. Numbers the same, zeros the game. 50 plus 10 is 60. Here I'm going to do 10 times 3 is 30. More on top, no need to stop. More on top, no need to stop. Bring the 21 up here. And 7 times 3 is 21. Numbers the same, zeros the game. Add these partial quotients. 10 plus 7 is 17. Now we need to check. To check, we do the divisor times the quotient plus the remainder. Divisor times quotient plus the remainder. But since both of our remainders are 0, and the identity property of addition says when you add 0, it stays the same, we don't need to take the time to add 0 if it's just going to stay the same. 3 times 0 is 0. 3 groups of 60, 6 tens is 18 tens. 3 groups of 7 is 21. Regroup the 20, bring down the 1. 3 groups of 10 is 3 tens, plus 2 more tens is 5 tens. Okay, 51, that matches my dividend, so that checks. 180, that matches my dividend, so that checks. So my numerator is definitely 17, and my denominator is definitely 60. All right, let's go ahead and fill in our data collection page. Okay, we are still in trimester 1. We are in week 12. Today is 10/21/19, and our fraction for today is 17/60ths. Okay, let's go ahead and get out your number line. We did groups of 3. Okay, so here's our 3. Go all the way over. Our last one is 13/60ths. 14/60ths. That's equivalent to 21/90ths. And 7/30ths was our simplest form. 15/60ths. That was equivalent to 45/180ths. And all the way down here, it's equivalent to 1/4. 15 is 15/60ths is 1/4. They're equivalent. 15 minutes is a quarter of an hour, 60 minutes. So that's why we call that quarter hour. 15 minutes is a quarter hour. Then we have 16/60ths, which is equivalent to 4/15ths. This is our simplest form. And then today, 17/60ths is our simplest form. There's no lines below it, or equivalent fraction in lowest terms. The only one that's above it is 51/180ths. Okay, go ahead and put your number line away, erase your worksheet, and thank you for joining me.